Welcome to BlockHero, the interactive guitar composer. The game starts with 4 chords in the same key and shows 4 buttons that can all be dragged to the bottom of the screen. The root block can take the user's typing input to show the desired chord, A through G, and the sharp symbol. The tone block can change from major to minor when the user presses the right arrow key. And when selecting the sus block, the user can choose the sustained interval from second or fourth by also using the right arrow key. All of these blocks can be used to change the 4 chords shown at the bottom of the screen. The screen also shows the name of the current key, and the user can manually set the tonic of the key using the root block. If I set the key to F sharp major, I will see all the chords in that key. But as soon as I change any of the chords at the bottom, it will recalculate to the correct key. The major and minor buttons under key switches to an appropriate minor in the opposite tone given the current chord progression. The play button plays all the chords shown in order. An important feature that made the play button possible was to open the mouse-pressed event as a thread in the pygame framework by Lucas Perza. Because of this, the finger positions shown on the fretboard change as the chords are being played. The music theory algorithms within this game are based on a dictionary containing information about major diatonic keys. This is initialized using a web scraping algorithm. This is the chart scraped from Wikipedia, and it shows chords in each diatonic major key. The web scraping turned that chart into these 2 dictionaries. Now you can see that if the progression contained only E major and A major chords, the key could easily be either E major or A major. The algorithm for finding the key takes advantage of the fact that Western chord progressions often end on the tonic, or the namesake of the chord. My algorithm for determining the key relies on the last chord in these ambiguous cases. In this example, the A root changes the key only when added to the 4th chord. The chord finding algorithm first collects the possible keys based on the current 4 chord progression using the common majority, and then it checks if the last chord matches any of those keys. If the progression does not end with the tonic, it cycles backward until it finds a chord that matches one of the possible keys. If it doesn't find a chord that is a possible key, it chooses one from the gathered possibilities arbitrarily and suggests to the user that they should end on the tonic to resolve their progression. This is an example of a resolved progression. And this is an unresolved progression. The game will also tell the user if they have created a chord that is not in the correct key. Now let's look at the neck or the fretboard of the guitar. It shows the finger positions for the chord that has been most recently modified or played or manually selected. Here it is showing the correct finger positions for the chord C major. An algorithm finds these finger positions by finding the first note in the chord on each of the 6 strings. The Y position of the circles was determined using a logarithmic scale based on 12-tone equal temperament or 12-tet tuning on a string of length L. In this equation, L is the length of the string and I is the finger position. When the user drags their mouse across the neck of the guitar, the selected chord plays. Notice that the time between each string being hit depends on the velocity of the mouse drag, much like on a real guitar. This was done by opening each note sound as a new thread, with a variable time delay between each one.